Deploying custom agent logic into an AWS managed hosting environment requires bridging two different execution environments. We're seeing a representation of that friction, custom code attempting to interface with managed infrastructure without a shared communication standard. The Amazon Bedrock AgentCore Runtime Service Contract is the mandatory protocol designed to solve this architectural gap. It defines a rigid topology. The contract specifies the networking standards, routing paths, and required payload shapes that the application must implement. Without exact compliance with this contract, an application cannot leverage the managed scale or the multi-agent discovery features built into the Bedrock ecosystem. The runtime supports 4 communication tracks: HTTP, MCP, A2A, and AGUI. This matrix maps each protocol to its specific engineering use case. MCP handles tool servers on port 8000, while A2A and AGUI manage agent discovery and user interfaces. HTTP on port 8080 handles direct API calls and real-time streaming. We will engineer a fully compliant HTTP protocol agent container from scratch to isolate the base requirements of the runtime. Mastering this HTTP dual pattern approach allows a single container to handle both synchronous REST tasks and persistent bidirectional data streams. Before writing application logic, we must establish the physical and network boundaries. The custom agent must be deployed as a containerized application, adhering to precise hardware specifications. This blueprint shows the required container parameters. The application must be compiled as an ARM64 container and bind to the host address 0.0.0.0. We then expose port 8080, the standardized entry point for all HTTP-based agent communication. Defining these foundational constraints ensures base compatibility before the container begins routing data or parsing payloads. With the container configured, we build the primary interaction endpoint, a post handler for incoming requests. Traffic flows into port 8080, routing to the /invocations path. The incoming payload must follow the application/JSON structure. The container processes inputs synchronously. Then the outbound path splits, a solid blue line for discrete JSON, or a segmented orange line for server-sent events. The non-streaming JSON path provides a single, complete response payload. This is the preferred method for deterministic computations and status confirmations, where the processing time is short. For more complex operations, we use the server-sent events, or SSE, format. This path requires the application to set the response header to text/event stream. SSE enables the container to deliver the response incrementally, preventing timeouts during long-running tasks, and allowing the user to see content as it is generated. The choice between discrete JSON and SSE determines whether the user experiences a blocked wait state or a responsive conversational interface. For bidirectional, real-time communication, the runtime provides an optional /WS WebSocket endpoint. Unlike the stateless interactions of the invocations path, the WebSocket connection is persistent and stateful. The connection begins with an HTTP GET upgrade request hitting the /WS endpoint. The request must include specific handshake headers, including connection:upgrade and the sec WebSocket key. The agent code returns response parameters to validate the handshake. By returning an HTTP 101 switching protocols response, the agent binds the session identifier to the tunnel, enabling simultaneous bidirectional data flow. Once the tunnel is open, the agent must maintain a continuous asynchronous listening loop to handle incoming messages. The stream supports text messages, which are used for structured data exchange between the user and the agent. We recommend using structured JSON blocks within these text messages. This allows the application to maintain clear message types and session tracking throughout the stream. In addition to text, the protocol handles raw binary messages. By implementing receive_bytes methods, the agent can process non-text data like live audio feeds or image files for multimodal analysis. Managing this lifecycle requires strict exception handling, but it provides the infrastructure needed for continuous, zero-latency multimodal interactions. The container must also expose its internal operational state to the AWS managed infrastructure. AWS uses a /ping get endpoint as a diagnostic heartbeat to monitor service health. The response payload indicates status, reporting as healthy when ready, or healthy busy when occupied with asynchronous background processing. If the agent is busy but fails to signal the healthy busy state, the runtime may assume the session has failed and terminate the container prematurely. Finally, the container must enforce security standards, specifically following RFC 6749 for OAuth 2.0 authentication. If a request lacks an authorization header, the agent rejects it with a 401 unauthorized status, bouncing it off the boundary. This rejection must include a www authenticate header, providing metadata so the client can locate the authorization server. Accurate state reporting and strict header enforcement protect the application from unexpected termination and secure the network boundary. We have now completely mapped the entire container topology, from the hardware constraints to the specialized routing logic. This completed model shows architectural efficiency. A single port 8080 manages API calls, WebSocket tunnels, and health monitoring simultaneously. By adhering to the contract's specific paths and lifecycle events, this custom logic perfectly integrates, locking into the managed Amazon Bedrock hosting ecosystem. When building an agent, developers must choose the path that fits their payload. Simple text requirements differ significantly from the needs of multimodal data streams. For most text-based applications, starting with the /invocations SSE stream provides the necessary responsiveness without the complexity of managing persistent WebSocket connections. Building a fully compliant AgentCore container meets the runtime's rigid requirements. This standard interface allows raw AI logic to function as a production-ready application.